This is a continuation of section 2.1 where we're talking about the quadratic function, and what we're going to do here is we've got several examples where we are going to graph and try to identify all the main important parts to the quadratic. There are several ways to get this information, but our goal is going to take this equation here and we're going to put it into vertex form. Your vertex form is y equals a x minus h squared and then plus k, because what we know about the vertex is it's the hk value. All right, we are going to now review how to complete the square. Completing the square is a process that puts our quadratics into vertex form. We have to use this form when it's not possible to factor our expression. And you can see here that this quadratic, the x squared, the minus 4x, and the minus 2, it does not factor. So here's how you complete the square. What we're going to start with is we're going to replace our f of x with y. And on the right side, we've got x squared minus 4x and minus 2. So the first thing that we're going to do is we're going to move the minus 2 to the other side so we get this out of the way. Add 2 over to the other side. I'm going to leave some space, and we've got the x squared minus 4x left. Okay, so our goal in completing the square is to write an expression here on the right side that I can factor into two binomials that are exactly the same. So once you move this 2 over to the other side, you are now ready to take half of your middle term. Half of negative 4 is negative 2. And you square it, and you add it to both sides. So you're squaring negative 2, that's plus 4. If you add 4 to the right, you have to add it to the left. Okay, what this creates is a perfect squared trinomial. So you got y plus 6 on the left side. On the right side, your x squared minus 4x plus 4, this factors into a binomial to the second power, and that's the purpose for doing this. That binomial is x minus 2. Okay, that minus 2 comes from that half term. If you do this where you square the middle term, it'll always create this trinomial that factors. So y equals, here we've got x minus 2 to the second, and then minus 6. So now we have vertex form, our vertex form, which means we know the vertex. So you pull out your hk, it's 2, negative 6. Our next thing is we're going to find the x-intercepts. Well, we can find x-intercepts as long as we let y equal 0. You can solve for x if y is equal to 0. So you set your y equal to 0, and you take your expression that we just solved for, or that we just wrote, and you're going to solve it. So you move the 6 back over. Obviously, you can use the expression from the step before. You got x minus 2 to the second, so you have to take the square root of both sides. That's plus minus root 6. And you do inverse operations to get your x by itself. So 2, adding the 2 back over, plus minus root 6. All right, there's our x-intercepts. So my x-intercepts are 2 plus minus root 6, comma 0. Now those are we can approximate those values so that we actually can graph them. And you just have to type those into your calculator, both the plus and the minus. And when we do that, we get 4.45. So we've got 4.45. Zero. And the second one is negative 0.45. Negative 0.450. All right, my y-intercept. My y-intercept is when x equals 0, and we can actually find that from the very original equation by putting 0 in for this expression. Put 0 in here, put 0 in there, you get negative 2. So my y-intercept is 0 and negative 2. Okay, the parabola opens up My leading coefficient here, my A is 1. There's no change in the stretch. And it has a translation of, after putting it into vertex form, you know, we're going 2 to the right and 6 down. All right, let's quickly graph this. So you've got your vertex at 2, -6. We've got x-intercepts at 4.45 and -0.45. I'm just approximating these, and there you have your y-intercept was at -2, so that can help you with sketching your parabola. So there you go. That's putting everything in vertex form and identifying the most important parts. All right, looking at example 2 here. So if you can factor this, you'd want to factor and try to use that as your way of identifying information, but this does not factor as well. So we're going to complete the square again. I'm going to move the 1 over, leave some space, -2x squared minus 4x. Another rule that we have for completing the square is that the leading coefficient here, -2, needs to be factored out. So I'm going to take this -2 out, which then becomes x squared plus 2x. Now we're ready to complete the square with my middle term. So I'm going to add half of 2. Half of 2 is 1. 1 plus 1, or 1 times 1 is 1. I'm adding 1 to the inside. If I want to keep my equation balanced, I have to add 1 times -2 to the other side. So I'm adding a -2. Trying to balance the equation, I've changed the right side, you change the left side along with it. So y minus 3 equals -2, you get x plus 1 to the second, and move the 3 back over. So y equals, now this is my vertex form, -2, x plus 1 squared, and then plus 3. All right, vertex is -1, 3. In order for me to find my x-intercepts, I'm going to set it equal to 0. So I have 0 equals -2 x plus 1 squared plus 3. You solve it for x, so subtract the 3. We're going to divide by the -2, which gives me 1.5. Take the square root, so plus and minus square root of 1.5 equals x plus 1. So after I solve that, I'm going to get -1 plus and minus the square root of 1.5. Those are my x values. So my x-intercept would be -1 plus and minus square root of 1.5, comma, 0. All right, those would also approximate to 0.22, 0, and -2.22. 0. So what I can use those for is when I'm trying to sketch the graph by hand. My y-intercept here, let's try to fix that too. My y-intercept is this value here. It'll always be that c value here with the quadratic, so 0, 1. The parabola opens, if you look at your last expression here, the parabola is going to open down because of the -2. There is a change in the stretch. It has a translation of, if you go back to your vertex, you're going left 1 and up 3. All right, here's what the graph would look like. negative 1, 3, vertex. X-intercepts are at 0.22 and negative 2.22. And you have the expression here. It was crossing the y-axis at 1, and so that can also help you. All right, there you go. There's the sketch of that graph. Example 3a, graph the following quadratic function. Now this one here, this trinomial is something that can be factored, and when I do factor it, I get x minus 5 twice, x minus 5, that's x minus 5 to the second. So this is in vertex form. So factor this, my vertex is 5, 0. The x-intercepts, if I set this y is equal to 0 and I solve for x, you take the square root of 0, you just get 0, and then you add the 5 over. So my only x-intercept is x equals 5. So 5, 0. We don't have any other way to write 5, 0. My y-intercept here, 25. So 0, 25. The graph opens, my form here, you can see the leading coefficient's positive, so it's opening up. There's no change in the stretch, and it's translated 5 to the right. Now let's graph this one. This one's a little different. So I've got my vertex at 5, 0. And I also know that's opening up, so in order for me to figure out any more values, you'd want to build a table of x and y values, input, output. Let's put 4 in. If I put 4 into my expression, 4, you'd want to put it in right here. 4 minus 5 and then squared is, you get 1. So over 4, up 1. This also would reflect, so at 6 and 1, and so there's your a good enough sketch here for us. We're just sketching. All right, next example we've got is going to, you want to look at the expression and make sure, there might not be a whole lot that we have to do with this problem. So you've got, let's go ahead and change this around. You got negative x squared minus 7. Because if you do that, you might recognize this is in vertex form. My vertex is 0, negative 7. X-intercepts, you set it equal, so 0 equals negative x squared minus 7. You solve, so 7 equals negative x squared. Negative 7 equals x squared. Well, this gives us a problem because you can't take the square root of a negative. So what this tells us is that there are no x-intercepts at all. Okay. The y-intercept is negative 7, so 0, negative 7. That graph is being shifted down. It opens down because of the leading coefficient. Okay, my a is negative. There's no change in the stretch. And it's translated because of the minus 7. It's just down 7. All right, let's look what we've got for a graph. So we got down 7. There's my vertex. It is opening down as well, and so you could build your table of values to figure out how wide. But it's our standard parabola because my leading coefficient was negative 1. All right, we've got this last problem here. So what I want you to do is pause the video and see if you can go through it and label all the parts, and then you can check your results. All right, so I went ahead and wrote out the problem and how to solve it and how to get the solutions and everything. If you want to check all your results here, you can do that to see how you did. And then here is your assignment.